Good morning everyone. Today we discuss about current electricity. In the previous chapter, we studied the phenomena associated with the electric charges at rest. Actually, the electricity is two types. One is static electricity, another is current electricity. Static electricity in the branch of physics where we discuss about where the charge at rest. So in the physics of charges at rest is called electrostatics or static electricity. That we discussed already in the previous chapter, previous unit 1. And now in the unit 2 we discuss about current electricity. Current electricity, so we shall now study the motion of dynamics of charges, as the term current implies some sorts of motion. So the motion of electric charges constitutes an electric current. So the study of electric charges in motion is called current electricity. So when charge at rest, then it is called electrostatics or static electricity. When charge in motion, then it is called current electricity. So in this chapter, basically we discuss about what is electric current, conventional current, drift velocity of electrons and current density, Ohm's law, resistance, resistivity, conductance and conductivity, temperature depends of resistance, color codes of carbon resistors, series and parallel combination of resistors, EMF and potential difference of a cell, then internal resistance of a cell, and series and parallel combination of a cell. So let's start. First we will know about electric current. So what is electric current? Actually, if two bodies charged to different potential are connected together by means of a conducting wire, charges begin to flow from one body to another. The charges continues to flow till the potential of the two bodies becomes equal. So the flow of electric charges through a conductor constitutes an electric current. The definition of electric current is the electric current in a conductor across an area held perpendicular to the direction of flow of charge is defined as the amount of charge flowing across that area per unit time. Or you can say also the rate of flow of charge, it is also called current. Or if there is small time difference dt, if dq charge flows through a conductor, then you can say also I equals to dq dt. Okay, so what is the unit of electric current? The unit of electric current is ampere. Okay, now we discuss about the different type of current. First, look here. First we discuss about the steady current. What is steady current? Steady current which does not vary with time. Look here, there are graph. We plot time with x-axis and current in y-axis. And look, this blue color line is actually the graph for steady current, where the magnitude of current is same. That means the steady current at which does not vary with time. The magnitude of current does not vary with time. Next, we discuss about B and C curve here. Look, one B graph is passing through, straight line passing through the origin, and another C graph is a curve. Here B and C varying the current whose magnitude varies with time. Okay. Now D. Look here, D another graph now. So this one graph, the alternating current, those the magnitude varies continuously and direction changes periodically. This type of current is called alternating current. Basically in our class 12, we discuss about the steady current and alternating current. But in this chapter, we discuss about only steady current. Okay. Now, we discuss about the conventional current. Basically, we know that the conventional current is the current whose direction is along the direction of the motion of positive charge under the action of electric field. Look, there is an electric field. So here the positive charge always, look here, the flow from positive to negative terminal, and electrons are always flows from negative to positive terminal. This conventional current due to the motion of electrons is in the direction opposite to that motion of electrons. So remember this thing, the flow of current always in the opposite direction of flow of electron. Now we discuss about drift velocity or current. Drift velocity actually defined as the average velocity with which the free electrons get drifted towards the positive terminal under the effect of the applied electric field. Look, this is a conductor and length of the conductor is L and cross section area of the conductor is A. And now we connect through a cell E, and here the electric field also E. So electron will flow in this direction. The drift velocity will be Vd equals to A into tau. Tau here is the relaxation time. Relaxation time means the time between two successive collision between two electrons is called relaxation time. So here the Vd will be, acceleration will be here small e capital E by m. So Vd or drift velocity will be Vd equals to minus E capital E by m into tau, or we can say also that the relation between I and Vd is I equals to NEAVD. Here the N is the number of electrons, E is charge of electron, and A is the cross section area of the wire or conductor, and Vd is the drift velocity. So current is directly proportional to the drift velocity. Clear? Now next we discuss about the current density. Current density denoted by J, and the current density at a point within a conductor is the current through a unit unit area of the conductor around the potential, provided the area is perpendicular to the direction of flow of current at that point. So J will be I by A, or actually we know that I equals to NEAVD. So J will be I by A. Now we put the value of I, NEAVD, divided by A cancel, so J will be NEVD. Or in the vector form, we can say J equals to I into I equals to J dot A. That's why we can say the current is actually scalar quantity. You know, is the electric current scalar or vector quantity? Look, electric current is scalar quantity. Why? This is because the law of ordinary algebra are used to add the electric current, and the laws of vector addition are not applied to the addition of electric currents. Simply I am giving example. In let consider two different currents of 3 ampere and 4 ampere flowing through any mutual perpendicular wire and just meet at a point. So total current flow through the another third portion will be 4 plus 3 means 7 ampere. So here the addition is scalar addition. Normal algebraic addition formula is applied. That's why here the current is called scalar quantity. Okay, now we discuss about the Ohm's law. So what is Ohm's law? Anyone? Look, Ohm's law we already did in the class 10 also. On the basis of observation of German physicist George Simon Ohm, delivered a relationship between electric current and potential difference. This relationship actually known as Ohm's law. Now we can say the Ohm's law is the current flowing through a conductor is directly proportional to the potential difference applied its ends, provided the temperature and the other physical conditions remain unchanged. So according to Ohm's law, you can say V proportional to I, or V equals to IR. So here if we plot a curve, if we plot a graph V versus I, then the graph will be straight line passing through the origin. Or if we plot for non-ohmic conductor, this graph actually for ohmic conductor. If we plot for graph for non-ohmic conductor, then the graph will be curved. Okay, remember this thing. So from this graph we can find the resistance of the wire also. Look, this graph is I versus V graph. So for I versus V graph, here the tangent will be delta I by delta V. So R will be 1 by tan theta. So 1 by tan theta will be R. So tan theta means here delta I by delta V. So delta I by delta V. So 1 by tan theta will be delta V by delta I. So this will be the resistance. Remember this thing. Okay. Now what will be the unit of resistance and what is the resistance? Resistance of a conductor is the opposition offered by a conductor to the flow of electric current through it. Okay. So what is resistance? The resistance of a conductor is the property by virtue of which it opposes the flow of charges through it. Clear? According to Ohm's law, you can say R equals to V by I. So it is equal to the ratio of the potential difference applied the across of the conductor to the current flowing through it. It is also, you can say. So R equals to V by I. So unit of resistance is the ohm. So 1 ohm equals to 1 volt by 1 ampere. Okay. Now we also know that I equals to NEA VD. If we put the value of VD, then the relation will be I equals to NEA into E into capital E by M into tau. Tau is the relaxation time. Or you can say I equals to NE square A tau by M into V by I. Or V by I equals to M into, this one is actually the I. So M into I into N square by A into tau. So R will be M into L by N square tau into A. So, or also you know that R equals to rho into L by A. Actually the factors affecting the resistance is number 1 length, number 2 cross section area, and number 3 is the nature of the material, and number 4 is the temperature. So we know that the resistance of a conductor for constant temperature dependence on length. If the resistance of a conductor is directly proportional to its length, so R always proportional to L. And cross section of area, number 2 cross section of area. If the cross section of area if the area of the cross section of a wire is A, then the resistance of the uniform conductor is inversely proportional to its area of cross section A. So R will be inversely proportional to A. So R proportional to 1 by A. From these two equations we can write R proportional to L by A, combined variation law. Or as when we want to remove the proportional sign, then we can write R equals to rho into L by A. Here the rho is the resistivity, or you can say also specific resistance. So what will be the unit of rho? Unit of rho is ohm into meter. Ohm into meter. Now we discuss about the relation between Vd, rho, I, E, J and V. So here the rho equals to E by J. So E by NE Vd. So Vd equals to E by NE into rho. So the relation between Vd and rho is inversely proportional. So if resistivity increases, then Vd drift velocity will be decreases. Clear? Next, when temperature decreases, then Vd also decreases and rho also decreases. Remember this thing. From this portion there will be a question. So when temperature increases, then Vd decreases and rho also increases. When I increases, then Vd decreases. Now we discuss about the conductance and conductivity. Conductance is actually the reciprocal of resistance is called conductance, and unit of the conductance is mho, 1 by ohm. It is called also mho. And conductivity is the reciprocal of resistivity. So this will be 1 by rho. Sigma equals to 1 by rho. Now we discuss about the temperature dependence of resistance. R equals to m into, we know that R equals to m into L by n square into tau into A. So when temperature increases, the number of collision increases due to the more internal energy and relaxation time decreases. That's why resistance increases. This is for conductor. For semiconductor, if we increase the temperature, then resistance of the semiconductor decreases. Remember this thing. So for conductor, if we increase the temperature, then resistance also increases, because there are number of collisions between two electrons are increases. But for semiconductor, resistance decreases. Now for conductor, we can say, if the resistance of any conductor at 0 degree Celsius temperature is RT, R naught, and in a T degree Celsius temperature, if the resistance is RT, then we can say RT equals to R naught into 1 plus alpha T. So here the alpha is a temperature coefficient. So alpha will be RT minus R naught by R naught into T, or you can say also alpha equals to R2 minus R1 by R1T minus R2T, where R naught is the resistance, is the temperature at 0 degree Celsius, RT is the resistance at T degree Celsius, R1 is the resistance at T1 degree Celsius, and R naught is the resistance at T2 degree Celsius. Okay, thank you.